Hi, hello there. Welcome to Address Resolution. Hosts and routers both create routing tables to ensure that they can send data and receive data across networks. So how does this information get created in the routing table? As a network administrator, you could enter these MAC and IP addresses manually. But that would take a lot of time, and the likelihood of making a few mistakes is great. Are you thinking that there must be some way that this could be done automatically by the hosts and routers themselves? Of course, you are correct. And even though it is automatic, you must still understand how this works because you may have to troubleshoot a problem, or worse, your network could be attacked by a threat actor. Are you ready to learn about address resolution? Let's get started. So this video lecture is entitled Address Resolution. And at the end of this video lecture, you should be able to explain how ARP and ND enable communication on a network. This includes discussions on MAC and IP addresses, ARP, and neighbor discovery. MAC and IP addresses. Destination on the same network. So sometimes a host must send a message, but it only knows the IP address of the destination device. The host needs to know the MAC address of that device, but how can it be discovered? That is where address resolution becomes critical. There are two primary addresses assigned to a device on an Ethernet LAN. You've got the layer 2 physical address, or the MAC address, and the layer 3 logical address, or the IP address. So the layer 2 physical address is used for NIC to NIC communications on the same Ethernet network, while the logical address, or the IP address, are used to send the packet from the source device to the destination device. The destination IP address may be on the same IP network as the source, or it may be on the remote network. So layer 2 physical address, example the Ethernet MAC addresses, are used to deliver the data link frame with encapsulated IP packet from one NIC to another NIC that is on the same network. So if the destination IP address is on the same network, the destination MAC address will be that of the destination device. Consider the following example using a simplified MAC address representations here. Okay, now in this example, PC1 wants to send a packet to PC2. The figure displays the layer 2 destination and source MAC addresses and the layer 3 IPv4 addressing that would be included in the packet sent from PC1. The layer 2 Ethernet frame contains the following. So you've got the destination MAC address. So this is the simplified MAC address of PC2. For instance, for the sake of demonstration, let's have 555555. The next one would be the source MAC address. Okay, this is the simplified MAC address of the Ethernet NIC on PC1. Say that is AA. So the layer 3 IP packet contains the following. You've got the source IPv4 address and the destination IPv4 address. Now the source IPv4 address, this is the IPv4 address of PC1, 192.168.10.10. Okay, now the destination IPv4 address, this is the IPv4 address of PC2, 192.168.10.11. Destination on the remote network. So when the destination IP address, IPv4 or IPv6, is on a remote network, the destination MAC address will be the address of the host default gateway. Example, the router interface. Consider the following example using a simplified MAC address representation here. Okay, now in this example, PC1 wants to send a packet to PC2. PC2 is located on the remote network. Because the destination IPv4 address is not on the same local network as PC1, The destination MAC address is that of the local default gateway on the router. So routers examine the destination IPv4 address to determine the best path to forward the IPv4 packet. When the router receives the Ethernet frame, it then encapsulates the layer 2 information. Using the destination IPv4 address, it determines the next hop device and then encapsulates the IPv4 packet in a new data link frame for the outgoing interface. In our example here, R1 would now encapsulate the packet with new layer 2 address information as shown in the figure. So in our example, R1 would now encapsulate the packet with the new layer 2 address information as shown in the figure. So the new destination MAC address would that be of R2 G0/0/1 interface, and the new source MAC address would be that of R1 G0/0/1 interface. So along each link in a path, an IP packet is encapsulated in a frame. The frame is specific to the data link technology that is associated with that link, such as the Ethernet. If the next hop device is the final destination, the destination MAC address will be that of the device Ethernet NIC, as shown here in the figure. Okay? Now, how are the IP addresses of the IP packet in a data flow associated with the MAC address on its link along the path to the destination? So for IPv4 packets, this is done through a process called Address Resolution Protocol, or ARP. For IPv6, the process is called ICMP v6 Neighbor Discovery, or ND. Address Resolution Protocol, or ARP. ARP Overview. If your network is using the IPv4 communications protocols, the Address Resolution Protocol, or ARP, is what you need to map IPv4 addresses to MAC addresses. So this topic explains how ARP works. Every IP device on the Ethernet network has a unique Ethernet MAC address. When a device sends an Ethernet layer 2 frame, it contains these two addresses. So first, you've got the destination MAC address, the Ethernet MAC address of the destination device on the same local network segment. So if the destination host is on another network, then the destination address in the frame would be that of the default gateway. Okay, so example is a router. Okay, next would be the source MAC address, the MAC address of the Ethernet NIC on the source host. So this figure here illustrates the problem when sending a frame to another host on the same segment on the IPv4 network. ARP functions. So when a packet is sent to the data link layer to be encapsulated into an Ethernet frame, the device refers to a table in its memory to find the MAC address that is mapped to the IPv4 address. So this table is stored temporarily in a RAM memory and called the ARP table or the ARP cache. The sending device will search each ARP table for a destination IPv4 address and a corresponding MAC address. So if the packet's destination IPv4 address is on the same network as the source IPv4 address, the device will search the ARP table for the destination IPv4 addresses. So if the destination IPv4 address is on a different network than the source IP address, the device will search the ARP table for the IPv4 address of the default gateway. So in both cases, the search is for the IPv4 address and the corresponding MAC address for the device. So each entry or row on the ARP table binds an IPv4 address with a MAC address. So we call the relationship between the two values a map. Okay? Now, this simply means that you can locate an IPv4 address in the table and discover the corresponding MAC address. The ARP table temporarily saves or caches the mapping for the devices on the LAN. So if the device locates the IPv4 address, each corresponding MAC address is used as the destination MAC address in the frame. If there is no entry, okay, for instance, if there is no entry that is found, okay, then the device sends an ARP request. Removing entries from the ARP table. So for each of the device, an ARP cache timer removes ARP entries that have not been used for a specified period of time. The times differ depending on the operating system of the device. So for example, newer Windows operating systems store ARP table entries between 15 and 45 seconds. Okay, so as illustrated on this figure here. Okay, now take note that the MAC address was shortened for the demonstration purposes. Okay, now commands may also be used to manually remove some or all of the entries in the ARP table. So after an ARP or after an entry has been removed, the process for sending an ARP request and receiving an ARP reply must occur again to enter the map in the ARP table. Okay? So how about the ARP tables on the networking devices? Okay, so in here, okay, on a Cisco router, the show IP ARP command is used to display the ARP table. Okay, and if you are using a Windows 10 PC or any Windows operating systems, okay, so the command is ARP-A command. Okay, so which is used to display the ARP table as shown here in the figure. ARP issues, ARP broadcasts, and ARP spoofing. So, as a broadcast frame, an ARP request is received and processed by every device on the local network. On a typical business network, these broadcasts would probably have minimal impact on the network performance. However, if a large number of devices were to be powered up and all start accessing network services at the same time, there could be some reduction in performance for a short period of time, as shown here in the figure. Okay, after the devices send out an initial ARP broadcasts and have learned the necessary MAC addresses, any impact on the network will be minimized. So, how about in some cases where the use of ARP can lead to a potential security risk? Okay, a threat actor can use ARP spoofing to perform an ARP poisoning attack. This is the technique used by a threat actor to reply to an ARP request for an IPv4 address belonging to another device, such as the default gateway, as shown here in the figure. Okay, now the threat actor sends an ARP reply with its own MAC address. The receiver of the ARP reply will add the wrong MAC address to each ARP table and send these packets to the threat actor. Okay, so enterprise level switches include mitigation techniques known as dynamic ARP inspection or DAI. But DAI is beyond the scope of this course. Okay, so take note that MAC addresses are shortened for demonstration purposes. IPv6 neighbor discovery. IPv6 neighbor discovery messages. So IPv6 neighbor discovery protocol is sometimes referred to as ND or NDP. In this course, we will refer to it as ND. ND provides address resolution, router discovery, and redirection services for IPv6 using ICMP version 6. So ICMP v6 uses 5 ICMP v6 messages to perform these services. So these are You've got the neighbor solicitation messages, okay? Neighbor advertisement messages, router solicitation messages, router advertisement messages, and redirect message. Neighbor solicitation and neighbor advertisement messages are used for device-to-device messaging, such as address resolution. So similar to ARP for IPv4. Okay, so devices includes both host computers and routers. Now, router solicitation and router advertisement messages are for messaging between devices and routers. So typically, router discovery is used for dynamic address allocation and stateless address auto configuration, or SLAC. Okay, so take note that the fifth ICMP v6 ND message is a redirect message, which is used for better next hop selection. So this is beyond the scope of this course. So IPv6 ND is defined in the IETF RFC 4861. So much like of the ARP for IPv4, IPv6 devices use IPv6 ND to determine the MAC address of the device that has a known IPv6 address. So ICMP v6, neighbor solicitation, and neighbor advertisement messages are used for address resolution. Okay, now this is similar to ARP requests and ARP replies used in ARP for IPv4. So for example, so PC1 here, okay, wants to ping PC2 at IPv6 address 2001 DB8 ACAD 11. Okay, now to determine the MAC address of the known IPv6 address, so PC1 sends an ICMP v6 neighbor solicitation message as illustrated in the figure here. Okay, now the ICMP v6 neighbor solicitation messages are sent using a special Ethernet and IPv6 multicast address. So this allows the Ethernet NIC of the receiving device to determine whether the neighbor solicitation message is for itself without having to send it to the operating system for processing. So PC2 replies to the request with an ICMP v6 neighbor advertisement message, which includes its MAC address. So that's the end of this video lecture. I hope you have learned something from this topic today. Have a great day.